Okay. Logistic is the best family function because it levels off over time. There's two ways to do this on the decimals and the calculator. On the calculator, we could do the following. Go home, new document. Don't save it, no. And I want a note, add a note. And I would like to paste this. And if you want to shorten that paragraph, go ahead. So, logistic is the best function because an elephant ceases to grow once it matures. That'd be a simpler sentence. Okay? So, I'm going to add to this I'm going to insert list and spreadsheet. And on top, this is age, elephants, okay, age, and whoops, go to G, and by the G is a symbol thingy, underline years, tab, and put elephants height, or no, yeah, elephant height in what? Inches? It's too long. Back it up. Still too long. Doesn't like it. Ella height. Inches. Okay, kind of weird. Okay, so I have to go copy the data. Where's my data? Who can read me the data? Yeah.
Age is, it starts at 0 and then increases by 2 until it's 1.
Actually, it skips 10 and 14.
Yeah.
And so I got caught first time I just did data set. So I put the data in. Now I'm going to go 2, 2.8, 4, 7.5, 10, 10.4, 10.45. Okay. So now let's maximize that. You should have this data in. Our next thing to do is go to doc. I can also press the doc key and insert a 7 data and statistic. My x variable is the age in years. My y variable is the elephant's height in inches. And there is the growth where it levels off. And now I've got to go to menu, analyze, regression, and show. It's none of these. I have to go down to logistic. D equals 0. That's your vertical shift. Should I shift it up from 0 when a baby elephant's born? Is it close to 0 in height? Yes or no? That's the question. I'm going to go with yeah, close enough to 0. And that's my logistic function that we're going to analyze. Okay. Now in this class, how did I do that? You did it? All right. So in this class, we'll have to do some algebra to figure out some of these pieces, and I'll give you a problem like that. But that's basically it. So now we can go back here and actually run the regression where the table is. Click there. Okay, holding. Get yourself to that cell. Make sure it's blue, not white. If you try to do it in there, it's going to mess up. So just make sure that's blue. Then we're going to do menu, statistics, stat calculation, and we're going to run the regression. And you got to go find the regression that you want. Logistic with D equal to 0. Yes. Let me go do that. Let me pause it. So here we go. So we have to run the regression. So let's do menu. And if you recall, that's a statistic that we have to do, procedure that I was taught, but I don't have to teach you. Great. God, thank you. So going down, and here's D equals not D 0. We said that an elephant's close to 0 when he's born in height. So let's do that. We got choose a variable. Click on the right thing here. I said right. And then click down and click tab. And then right.
That's elephant's age, right?
Yes, age in years. I defined that earlier. Now his height. Click tab again. And F1, I'm good with that. Keep going until you get to OK, tabbing. And then when you get to OK, press enter. Okay, there's your regression. Let's pause that. Okay, so what does this tell me? this tells me that logistic regression, the B is 0.31. The C, which is the carrying capacity of this model, is 10.7, which represents 10.7 feet, the maximum height the elephant's going to reach, according to the data. Okay, let's take a look at what this looks like. We go to document again, and we're going to insert this time a graph.
Wait.
Like that.
Insert what?
Insert a graph.
Graph?
Yes. And then go up, and see that? There's your model. 10.7 plus 1 plus 5.45 e to the negative 0.31.
You gotta...
Press enter.
You got this.
Yeah. So, when you're at the tab, you go up, then press enter. That will appear. Here goes. So, this is the deal. And now I gotta set the window. So menu, action. No, window settings, excuse me. Escape. Window settings. And then I'm gonna go from -10, -2 days. I'm gonna go -2 days to, I don't know. That's years. How old do you think this elephant's gonna get? 70?
Yeah, 70.
And then the height, -6 is good. How tall is this thing gonna get? 15 feet high, at most, or less than that. So there it is.
You put 15?
I put 15. And now I'm gonna go menu. Then I'm gonna do one of these graph entry 3. And I'm gonna put the scatter plot on there.
The what plot?
Scatter plot. Menu 36. And then I'm gonna pick on the variable, and that's age in years. Then press tab, and then variable again that's above the 9 key. And this is his height. And I'm gonna press enter.
Hold on a minute.
And
Can you go back real quick? I didn't see that.
Yeah, I'm just gonna watch the video when you upload it.
let's see. That makes sense. Okay, so there's a screenshot of that. Let's do it again. And we could answer some questions. Let me stop the video there for that part. I was hoping to do 2 parts. And I guess I
Do
can.
that underscore thing.
It's by the G.
The G.
Look at the G key, and by the G key is that symbol key. Click it. Okay, so
What was it? Asian what?
hold on. Okay, let's switch to the other application, the Desmos, and see how that works out. This is the data that we have, the elephant in ears. Let's copy and paste that. We can do this. And here's my 5.4. Here's the data. Let's title the graph. 4.6 logistic function models. Save that. Save it. So let's put, that's at a table. And let's add the note. Zero, 2, 4, 8, 12, 16, 20, backing it up, 2, 2.8, 4, 7.5, 10, 10.4, 10.45, so that we have elephant height in feet, age in years. So let's maximize that. Let's set that. Let's scoot this over and say that this is the elephant's age in years. that goes from, say, -2 to, I don't know, 50 years. Step of 1. The y-axis we said was the elephant's height in inches. And we said that was going to go from, say, -10 to, not in inches, in feet. What am I saying?
Hello, mister.
In feet. Hello. So let's put that from -10 to 50. No, 15 or 20 by 5s. And there it is. From 0 to 50 in years and 0 to 20 in feet. And here's a data point seems off. Let's see what that data point is. 0.8. So that's not supposed to be 0.8. I think that's supposed to be probably 8. Let's double check the data. Let's go back here. 7.5. Okay. 7.5, data entry problem. And let's do that. And we saw earlier that the logistic function, so you should know y1 is what you have to do because y1 is your data here, and x1 is the independent variable. Find the tilde by opening up the keyboard, click on ABC. On this row you have the tilde or the similarity key. It's not equal, it's más o menos, more or less. And then we're going to write the limit. We could ask the computer for the limit, just put L divided by 1 plus, it's always 1 plus A, times E, so right, type E, over here I have to go to the E, like that, and then to the power of X, 1, like so. And that looks odd. I forgot the B. So let's put the B. Like so. Let's see. We've got to redo that. B up there. There it goes. B has to be up there with the X1. Okay, let's plot the residuals, the first differences, and we see that's a pretty good match. And now we can ask some critical questions like, what is the function's value at year 0? What is the y-intercept? Well, I don't have a function. I'd have to write it. So using that would be f of x equals, again, the limit L divided by 1 plus A that I've already defined using the regression times E to the power of x in this time, because this time this is a function in x. And backing up, I forgot the B again, bx. So now I can ask the question, what is f of 0? There's your answer. Apparently 1.6. Now, I can put plus 1 here, or 2, or 0, whatever you like, for the function. If I put plus 1, how does that affect it? Now the elephant is 2 feet, 2 feet tall at birth. If I put 0, then it's 1.6 feet at birth. And I would like to know when approximately he levels off. So if you look at the graph, you see that around 20 or 20 something it levels off. And we could put a level, a carrying capacity. We could say y equals, and I think if you go up here, you read it off the graph, or off the regression, it's 10.7 feet, or thereabouts, 10.76. And then you can ask, okay, when will I be at 10.76? So f of, is it 20? Is that 10.76, or is it 23, 24, 25, 37? There you go, 37, 38, 38, almost. 39, okay, 40, 41, 42. When is it going to get to 43? 43 is 10.76. So at 43 years of age, the elephant reaches the maximum height. So let's put this down like this and take a screenshot of this. And those are typical questions that I can ask. Let's go ahead and do that. Stop the recording. Please submit that 2 screens for the Inspire and 1 for the Desmos version.